All right, guys. So we finished the quadratics units, right? Chapter 4, you guys took your test. I'm almost done grading them. I'm on the back page of everybody's right now. So hopefully tomorrow we can get those back to you. Some are really great. There's a couple not so great. So, I mean, a lot of people miss like a couple points on each page, just like little things, plus minus, didn't simplify, just some small stuff. Overall, I'm not upset. Does that make you feel better? Hopefully I'll get them finished today and then back to you tomorrow. That's a hope. I know I need to grade it. I haven't graded it yet. It's in my to-do list. I promise. It is. All right, but guys, today and tomorrow we're going to do a little bit with graphing. Today we're going to graph by hand. Hopefully a lot of this you've learned before. If not, I'll teach it as if you've learned nothing. And then tomorrow we're going to look at the graphing calculators and how all of that transpires to a graphing calculator and how those can work to graph. And then we'll move into chapter 5, which is polynomials, which is like x squared, x cubed, x to the fourth, x to the fifth, x to the sixth. Like, how many answers will I have if it's an x to the sixth? 6 answers. So the graphing calculator becomes your best friend in the next chapter as it moves on. But we need to understand basic graphing and then graphing in the calculator before we can jump into that chapter. So first thing, preparing the graph. We need to make sure things are in standard form. What does standard form look like? She's right with the A. Anybody help her out? So what? There it is. Let's see. Good. So that's your standard form, right? We had everything last chapter, moved back to standard form. Today we're only working on graphing quadratics by hand. I will never ask you to graph anything more than a quadratic by hand, like for exactness, because it's just too hard. A blank is the graph of a quadratic function. Do you know what that shape it makes is called? Do you know what shape it makes? I should ask that first. A U? Could that U be flipped upside down? Do you know what that shape is called? Starts with a P? Say it again. Close. It's called a parabola. It's spelled parabola, but don't say it like that. Parabola. Parabola. All right, and then the path of any object flying through the air, hence my Angry Birds theme for these notes, because I always picture the Angry Birds flying. It's described as a parabolic shape. Parabolic. Now, you know baby brother, like we kept, factoring out? If I throw him through the air, he makes a parabolic shape. Any object flying through the air, you toss it. Throwing the football Friday night, right? You kicking it or missing your kick or whatever, right? It's flying. It's going to be parabolic. All right, so we're going to kind of baby step our way through this. So put the equation in standard form and name A, B, and C. So very first one, what order should it be in? Carson. Robert, what's my A value? Robert, what's my A value? A. 2. Robert, let's try again. What's my B? There you go. And C? Negative. Negative 11. Oh, he's rough today. It is. I totally get it. All right, number 2, Jacob, what order should that be in? Good. Corbin, what's my A value? Just 7? Negative 7. There you go. How about the B? Can you tell me that one too? Do you know what the C is? Very good. All right, number 3. Alavea, what order should that be in? What happened to that? Is it already in standard form? Is the 2/3 any different than how this -7's attached? Is it any different than how the 2 is attached? No, it's just a number. It's just a number. So it's already. Yes. Yes. F of x and y, f of x is just like a fancier name. I always like call him Frank. Right? If you're like writing a bunch of equations, like solving things, my brother-in-law's name is Frank. That's what always comes to mind. But like when you're writing a lot of equations, if you name them something that makes sense, P of x, I would write for pancakes. F of x for flour. I don't know, whatever you want, okay? But like if you name it with different letters, it helps you tell what your equations are. So it's just a fancier, more dignified name. That's all it is. My nephew actually sent me a text over the weekend, and it was like a text between a kid and a mom. And the mom was saying, like, texted him, said, you need to clean your room. And he said, why? Like, literally just the letter Y. She said, because I told you so. And he said, why? And then she said, would you stop asking me why? And he said, F of x. Thank you. That's funny. Because F of x and Y mean the same thing. So my nephew, he's a freshman. I thought it was really funny. All right. So number 3, my A value, just theory. 2/3. What about my B? What's B? What's C? A red 0. All right. So we should know how to do this already, correct? All right. Moving on. What does standard form tell us about the parabola? So we can tell some things about the graph without actually doing any math on it, just by looking at the equation. So the point where the parabola changes direction is called the what? The what? Close? She was really close. It's called the vertex. Vertex. Right? So baby brother's flying through the air. At the point where he stops going up, it starts coming down. That's the vertex. Yes. Sorry, I know I didn't. I'm sorry. I'm sorry. I'm sorry. Write it in the margin. That's my bad. I'm sorry. All right. It opens which direction if the A is positive? It opens up. Right? Can you picture what it looks like? It looks like a U. And it has a blank point or value. My vertex is way down here. A minimum value. The vertex is the minimum. Why? It's the lowest point on that graph, right? So the vertex is a minimum. That always throws people because they're like, wait, it's positive and it's pointing up. Shouldn't it be a maximum? But no, it's actually the lowest point of the graph, so it's a minimum value. And it opens which way if A is negative? It opens down. And the vertex will be a maximum. Yay! Because it is the highest point, right? Baby brother flying through the air. His maximum is the vertex, right? It's his highest point before he falls back down. Don't go home and throw your siblings around, okay? All right. So decide whether the parabola will open up or down and whether it has a maximum or a minimum point. So again, I'm not graphing anything, but I can get an idea for what it looks like. So number 4, will it open up or down? Take a look at your A value. My A value is a 2. So since A is positive, it will open up, right? It's going to look like this. It's positive with a smiley face. Yay, positive, smiley face. All right. Will the vertex be a maximum or a minimum? A minimum, right? My vertex is going to be way down here. It's going to be the lowest point on my graph. Okay, number 5. My A value is a 2. Good, this is not in standard form. There's your A value. Is it going to be opening up or down? Up, because it's positive. A is positive, it goes up. And that's a minimum again, because it's going to be the lowest point on the graph. And number 6, down, because my A value is negative. So it's going to open down. It's sad, right? It's negative, it's sad. Sad face. So it opens down, and it has a maximum point, because now my vertex is the highest point on my graph. So sometimes just that visual helps you realize whether it's a max or a min, right? Questions there? No? All right. So now we're going to kind of slowly step into how do we graph these by hand. So first thing we want to always know where it's located is the vertex. Okay? So the x-coordinate of the vertex is negative b over 2a. Does that sound somewhat familiar? All over 2a, right? Negative b plus or minus all over 2a. So yeah, that's kind of part of, except for the discriminant part, right? Yep, so x-coordinate of the vertex, negative b over 2a. So we need to know that. We need to memorize it. So this is how we find the x-coordinate. So if we look at this example over here, it's in standard form. Let's do negative b over 2a. What's my b value? 8, so negative 8 over 2 times a. What's my a value? 2. Now, some of you are very calculator dependent people. That's okay, no judgment here. But if you're typing all of this in your calculator, you can't do it all in one line unless you do it the correct way. Okay? Now, here's my suggestion. Can you do the bottom in your head? Okay, clean up the bottom first. So 2 times 2 is 4. Fish is the only other acceptable answer. All right. And then negative 8 divided by 4 is negative 2. So that is finding the x-coordinate of the vertex. Now think about when you're graphing, everything's an x and then y. So to find the y-coordinate of the vertex, you just plug the x that you just found, plug it back into the original problem. So I'm going to take that, I'm going to plug it in. All right, so it's 2 times x squared. My x is negative 2. All right, so I'm just plugging it in right here. I can write it over here if you want. So 2 times negative 2 squared. I'm plugging it into the equation. Plus 8 times negative 2 plus 5. Can I type that whole thing right in my calculator? Sure can. So what do we get? So negative 3. So my vertex then is located at negative 2, negative 3. Would that be the highest point on this graph or the lowest point on that graph? It'd be the lowest. My a value is positive, so I know it's going to open up. So then that vertex is going to be located at negative 2, negative 3. It's going to be the lowest point on that graph. Everything else should go up higher. Okay so far? All right, so let's just practice finding a vertex. Baby steps, right? So let's do a couple together, and I'll let you try some on your own. So number 7, finding the vertex is negative b over 2a. So negative b is negative 4 over 2 times a, which a is 2. So clean up the bottom. 2 times 2 is 4. Negative 4 divided by 4 is negative 1. Okay, so your first step is to just do negative b over 2a, figure out what that is. That's your x value. And then to find the y, we just plug it back in. So 2, so in place of my x, I'm plugging in negative 1 squared plus 4 times negative 1 minus 7. So anywhere there was an x, I plugged in my x value. I'm going to see what I get. So what do we get? Negative 9. Sorry, I had a brain fart there for a second. So my vertex is located at negative 1, negative 9. Is that the highest point or the lowest point? It's the lowest, because it's going to point up. All right, how about you guys try number 8 on your own? All right, so first thing, negative b over 2a. So negative b, so I'm going to actually make that a positive 6 over 2 times my a value is 1. So 6 over 2, which is just 3. So the x part of my vertex is just 3. All right, from there, I'm going to go ahead ahead and plug it back in. So 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 is negative 9. Yeah, so negative 4. So that's what we should have gotten. 3 negative. If you did not get that, take a look at what my work is, look at your work, see if you can figure it out. If not, ask so I can help you out. Because if we can't get the vertex, then your entire graph will be wrong. Because it's always based off your vertex. I know, right? All right, let's take a look at number 9. So negative b, what's my b value? 0. Can I have a negative 0? Thank you for saying no. Just 0. Over 2 times a, so 2 times 3. So that gives me 0 over 6, which is just 0. All right, and then we have to plug 0 back in. It's not all going to be 0. It's negative 4. Yeah, so make sure you're always plugging it back in. All right, and then number 10. We got this? On your own? All right, on your own. All right, guys, let's go ahead and take a look at this one. So negative b is going to make that positive 3 over 2 times a. What's your a value? It's negative 1, because your a is sitting back over here. It's not in the right order. So we end up with 3 over negative 2. All right. Fractions are just numbers, so don't panic on those. Okay? So we just have to take that and plug it back in just the same way we did the other ones. So 1 minus 3 times negative 3 halves minus negative 3 halves squared. Now, I want you guys to pay close attention to how I plug that in. Just because there's a minus here doesn't mean you don't have to write it here. Negative top or bottom doesn't matter. Just some calculators don't like it on the bottom, so I always put it on top. All right, so just be careful. Anytime you have a minus and then you're plugging in a negative, you still have that negative there. So you have to type all that in. Does anyone not know how to type in a fraction on the graphing calculators? If you hit the green alpha button and then hit y equals, which is 2 buttons above that, and hit enter, you can put in a fraction. So what did we get? Uh-oh. So 1 minus, let me type it in, 3 times negative 3. You can put it in standard form. It's not going to really change much. Minus negative 3 over 2 squared. I got 13/4. If you did not get 13/4, let me see what you're typing in. All right. So if I would ask you to graph. So like, let's go back to what, like 7th grade maybe? Where you were graphing by hand? Maybe earlier than that. Do you guys remember making like XY tables? So how did you graph using an XY table? Good, that's usually what you typed in, right? Negative 2, negative 1, 0, 1, 2. You wanted to see on the negative side and you wanted to see on the positive side. The board has a mind of its own sometimes. All right, so when you figure out what numbers you plug in, could I have plugged in any numbers I want? Yeah, anything I want. But I mean, I want to try to pick numbers that are going to stay on my graph, right? I could put in 1,000,000, but that's not fun to graph. All right, so when we're typing this in, I could have plugged in anything I wanted. And then we just plug them into the equation, right, to get our answer. So what's negative 2 squared? This is where you answer me. What's negative 2 squared? It is positive 4. Negative 1 squared? 0 squared? 1 squared? 2 squared? There we go. And then what did you do with these points? You graphed them. You plot your points, right? So negative 2, 4. So back 2, up 4. Negative 1, back 1, up 1. 0, 0. 1, 1. And 2, 4. Can you see what that looks like? Will it have a point on the bottom? No. Parabolas are not pointed. Okay? It comes down to a single point, but it's going to come down smoothly and just kind of round it and touch it and then go back. Okay? So do not draw your graphs with a V shape to them. Those are absolute value graphs. So these are not pointed. These are nice and round, curved. Carson? Don't make it pointed. Nope, don't make it pointed. Can you tell me what the vertex is of that graph? 0, 0. Okay, 0, 0. Could I have found that out by using negative b over 2a? I could have. Okay, but yeah, I can see it's 0, 0. It's the lowest point on the graph. What do we know about the right side of the graph versus the left side of the graph? They're what? They're symmetrical. That was the word I was looking for. It is positive, but it is fun. Do you guys ever do those art projects? I remember doing when I was a kid, where you take a piece of paper and you put paint on one side, and then you fold it in half, and then you open it. Butterflies, yeah, and it makes some symmetrical painting, right? So it's kind of like what we're doing here. If I would fold that right where the vertex is, that's kind of my fold line. It's called the axis of symmetry, if you really want to know what it's called. But if I would fold it, it should be the same on both sides. Now, I've told you many times I'm a lazy mathematician, yes? Oh, very lazy. So do I really need to find all of those points? Because if I find the points on one side, I know what they'll be on the other side. Yeah, I can just graph them that way, which is what I'm going to do. So we can bypass this. This is just a recap of what we're doing, because I used to teach this over 2 different days and some different stuff. But I've changed it. So here we go. So let's find the vertex. We're going to graph this. I'm going to show you how this works. So find vertex first. So negative b over 2a is what we start with. So negative b is what? 8 over 2 times a. So it's 8 over 4, which, yes, Carson, is 2. That's all right. Okay, how do you find the y value? Plug it back in. So 2 times 2 squared minus 8 times 2 plus 6. Did I hear a 6 in there? Negative 2. 4, 2 is 8, minus 16 is negative 8, plus 8 is negative 2. All right, so let's go ahead and plot our vertex. So it's at 2, negative 2. So over 2, down 2. Now, me personally, I find it easier, especially just starting out. I draw kind of that dotted line through my vertex. It's kind of like on the art project, that's your fold line. So where you folded it, so I know that one half's the same as the other half. It's called the axis of symmetry in algebra. All right, I know then where one side should come together to make the other side the same. So that just kind of helps me visually see that. All right, so we're going to make a table of values, just like we did on the last one. And I can plug in anything I want. Yes? Will they always stay on my graph? No. If I plug in 100, it's not on my graph. All right, now I want to make sure I can be as lazy as possible. And I want at least 2 more points on the other side that I can reflect on the other. That's what I want. So here's what I find is the easiest. Whatever your x value is, which is a 2, I'm going to go 3, 4. To make sure I find things that are as close to my vertex as possible to give it the best shot of staying on the graph. Still, sometimes it flies right off my graph. There's nothing I can do. Okay, so if my x value was a 5, what would I plug in? I'd go 6, 7. If it was a negative 3, what would I? Negative 2, negative 1. Now, granted, I could put anything in I want. So that's not necessarily wrong, but it probably won't stay on your graph. So I'm just trying to help you find points that will stay on the graph with you. All right, so I plug in a 3. What do we get? You got 8. Somebody check. You got 0. So let's try this. Now, do you guys know how you can kind of help yourself out on the calculator? Yeah, you can go up enter again, and you can just change out the one number every time. So 2 times 3 squared minus 8 times 3 plus 6. I got 0. That should be 0. So whoever's getting 8, you're wrong. Oh. Yeah, so guys, if you already typed this in your calculator from the vertex, if you just arrow up to it and highlight that equation, hit enter, it brings it back up for you. Then you can go in and just wherever your parentheses are, change it out to a 3. So again, lazy, you have an older calculator. So I'm going to try it again for the next number. I'm going to bring that equation up. I'm going to arrow back through, and I'm going to change all my 3's. I'm going to change them out to a 4. So if you always put it in parentheses when you substitute it in, it's easy to see where you need to replace them. And you get a 6. All right, so let's go ahead and plot these. So 3, 0, and 4, 6. And I found 1/2 of my graph. How do I find the other half? Oh, Carrie, I love you right now. So do you see how this first point I graphed was 1 space away from that line I drew? So where should it be on the other side of that line? 1 space on the other side. And my second point that I graphed was 2 spaces away. So I'm going to go 2 spaces away on the other side. I want to make sure it's the same. It's got to be symmetric. And then I can draw my parabola. If you're like me, I am terrible at drawing graphs. Sometimes I completely miss my points. So you know what I do when I miss my point? Make the point bigger. By definition, a point has no size. So I just make it bigger. Stop. You're right, it has no size. Are we seeing how it can be fairly simple to graph? You only have to find the points on one side. Give me at least 2 points other than your vertex, and then you can reflect them on the other side. Okay? Now, back to what we had first did. We talked about I can look at this. My A was positive, which means it should be pointing up, which it is, right? So you can look at that and you can kind of double check your graph. The other thing that you can look at, that C value is always your y-intercept. Do you know what that means, y-intercept? Where it intercepts or crosses the y-axis. I was thinking football, right? Throwing an interception, someone ran across your path and caught the ball. So it's where it's crossing the y-axis. Look where that point is on the y-axis. 1, 2, 3, 4, 5, 6. That's exactly where that is. It could be one of your points. Now, if that's already your vertex, though, no. But yes, it could be. All right, let's try the next one. What do I know right now about this graph? Jasiri, good morning, sunshine. You're sleeping. Jasiri, what do we know about this graph before I even graph it? What's it going to look like? Give yourself a nice stretch first. Is it going to point up or down? It's going to point down. Right, so I know when I'm graphing this, my end graph better point down. There's nothing worse than somebody has a negative and it's pointing up. I'm like, really? That wasn't a red flag to you? Something was wrong? All right, so finding our vertex, negative b over 2a. So negative b is going to be negative 8 over 2 times my a, which is negative 4. So I get negative 8 over negative 8, which is 1. How do you find y? Plug it in. So negative 4 times 1 squared plus 8 times 1 plus 2. Now what do we get? We get 6. Good. So my vertex is at 1, 6. I'm going to go ahead and graph that, 1, 6. And I'm going to put my dotted line just because it helps me when I'm graphing those, plotting my reflection points, right? It's easier for me to see, okay, it's how many spaces away from that kind of fold line, the axis of symmetry. All right, so now I need to plot. I need to do 2 points. So what values should I plug in for x? 2 and 3. Yeah, again, because my x value is at 1, so I'm going to go to 3. I could put anything I wanted in, so don't think you couldn't. I'm just trying to keep it on the graph. All right, so this is where if you already had that typed in, makes it pretty easy. For 2, it's 2. What about for a 3? You can just go in and change your 2's out to a 3, and it is -10. Now, what if I plugged in a 4? Would I stay on my graph? No. See how that's dropping? It would drop way off my graph. All right, so we're going to plot 2, 2. Right away, when I plot that, I can see it's 1 space away from my line. So what should I do? Can I reflect it then on the other side? Go 1 space on the other side. And then we had 3, -10. That's 2 spaces away, so I'm going to go 2 spaces on the other side. Okay, and then I can draw my graph. It's a very skinny, long graph, but there it is. Just the way numbers worked out. Now, do me a favor, look at your graph. Do you have arrows on the ends? If you do not, it is wrong. Why do we put arrows on? It's infinite. It keeps going forever and ever and ever, right? Does that make sense? Because I could have plugged in a 4, right? If I plugged in a 4, it'd be even further off my graph. But it will keep going and going and going. Good. You guys want to try one on your own? All right, guys. So -b over 2a. What's my b value? 0. So 0 over 2 times -2 gives me 0 over -4. But 0 divided by anything is 0. And if I plug 0 back in, it is just 1. So your vertex is located at 0, 1. So my axis of symmetry, or my fold line on my art project, is actually the y-axis. It's right on top of it. All right, so making our xy table, what numbers did you plug in for x? Okay, so this is at 0, so I went 1, 2. That's what I would go. Technically, you can plug it in anything you want. I don't care. So plugging in a 1, what do we get? We get -1. Plugging in a 2? Good. So 1, -1. That is 1 space away from my line, so I'm going to go 1 space on the other side. And then 2, -7. And that's 2 spaces away. I'm going to go 2 on the other side. And then I can draw my graph. Ooh, I almost missed that point. Stretching, just barely. All right, so the question came up, what happens if I go to do this and only like one of my points stays on there? Do we assume we did it wrong? No, doesn't necessarily mean it's wrong. Now, if you find one point that's like down here and then the next point's up here, then you should worry that something went wrong, okay? They should either make a nice, beautiful U or an upside down U. You shouldn't have like W-shaped things going. That's x to the 4th, not by hand. We won't do it by hand. All right, so guys, let's go ahead then and take this one step further. Let's go ahead and graph this, and then I want to kind of talk about what it means. All right, so as we graph, what do we start with? Wow. Good. -b over 2a. Like, wow, we forgot already. So -b is -2 over 2 times 1. So it's -2 over 2, which is -1. How do you find y? Plug it in. So -1 squared plus 2 times -1 minus 8 is -9. So my vertex is -1, -9. I'm sorry. It's fun. What do you mean what do I expect? I expect to have fun. This is amazing. All right, so let's go ahead and plug in values in our XY table. Good. My x was at -1, so I'm going to go 0, 1, just the next two numbers. If I plug in a 0, I get -8. And if I plug in a 1, -5. Go ahead and plug in a 2 as well, just to humor me. Plug in a 2. 0. Good. All right, so let's go ahead and plot this. So 0, -8, so down 8. And make sure you reflect it. 1, -5. And reflect it. Now, when you're reflecting, be careful that you're reflecting over that dotted line that you drew, not just over the y-axis. I have some people who only want to do it over the y-axis. It's over your line that you drew. All right, and then 2, 0. That's 3 spaces away. I'm going to go 3 on the other side. All right, and then we can draw our parabola. Parabola. All right, beautiful graph, right? Now, let's kind of tie that to what we did in the last chapter. If I asked you to solve this problem, what method would you pick? Quadratic formula would work, but I think there's a faster method. It'll factor. So let's go ahead, set this equal to 0. Yes, and what you're doing instead of y, you're actually going to have y is 0. You're going to plugging it equal to 0 and seeing what happens. So if I would factor this, my last one's negative, so what are my signs? Opposite. X and X. Good. +4, -2. So what would you tell me x equals? -4, +2. How does me solving that go with the graph at all? I solved for x, correct? Look at your x-axis. Where did it cross the x-axis? -4 and 2. Oh, will that always happen? Yes, it will. If you do it right, yes, it will always happen. Your answers when you're solving are the same things as when you graph it where it crosses the x-axis. Yay. Knowing that little fact helps us so much in the next chapter, recognizing that. Lydia, did you have a question? Great question. What if there's an I? What's I stand for? It's imaginary. It will not cross the x-axis. Right? Like if I would have a graph that the vertex was here and it went like this, and it never crossed, that means its answers are imaginary because it never crosses. It's a great question. All right, let's take a look at another one. So y equals x² - 5. Okay, so if I'm going to graph -b over 2a. So my b value is 0 over 2 times 1, which is just going to be 0. If I plug 0 back in, it's just -5. So there's your vertex, 0, -5. So then my axis of symmetry, or that fold line, is going to be right over top of my y-axis this time. What numbers are you plugging in to the table? Good. Again, because this is at 0, I'm going 1 and 2. So plug in a 1 and plug in a 2. Go ahead and give me a 3 just for fun. Good, it's 4. All right, so 1, -4, and reflect. 2, -1, and reflect, and then 3, 4, and reflect. Now, why did I ask you to do one more point? Good. It's going to extend it further because my first points that I did, normally I just do 2. You see how it never crossed the x-axis? If I do one more so that forces me to cross it, I get a better idea of where it's going. Okay, that's why I did an extra one. Same thing on the last problem. I did the same thing because my first points that I did not cross it. So I did one more to make sure I at least crossed it. Okay. So what method would you like to use to solve this? Square root method. There's no b term, right? So if I have x squared minus 5 equals 0, good, x squared equals 5, adding that over. Yeah, 5. All right, and then take the square root. So x equals what? Plus or minus radical 5. Somebody do me a favor, grab your calculator. What's the square root of 5? Big ugly decimal. 2 point something? Look at my graph. Where did it cross the x-axis? About 2 point something, and do you see the negative 2 point something? So here's the positive radical 5, and here's the negative radical 5. So the plus minus is because you have 1 on the plus side and 1 on the minus side. Come on, nobody's mind's blown? Like, that's amazing though, right? It's amazing. I love how that works together. Maybe. I don't know. It's not my job. All right. So just a little bit of vocab for you guys. The solutions to the quadratic equation are the points where the graph crosses the x-axis. We just saw that, right? We did 2 examples where that happened. These solutions for those points, they have some different names, and I want you to be aware of what the different names are depending on what mood I'm in, how I say them that day, what textbook you're looking at. They can use different words. They all mean the same thing. They are called x-intercepts. No. Does that make sense? X-intercepts? Where did it cross? The x-axis. So x-intercepts make sense. They can be called zeros. Why would they be called zeros? Because that's where what equals 0? When you solve your equation, you set it equal to 0. 0 went in place of what variable in your equation? In place of the y. So it's where your y value is 0. That's why they're called zeros. Or they were called the roots. When I taught in Finley, the textbook that we used there, they used the word root all the time. But personally, I don't like that word. I use zeros more often than anything. I'll say find the zeros of the equation. So all I'm asking you to do is just solve it. Okay. The zeros meaning where does y equal 0? Where is it crossing that axis? Okay. So again, if I ask you to graph, yay, we can do this now, right? We can graph. So negative b over 2a. So what's negative b? This is the classroom participation portion of the class. B, 8, good, 8. Over 2 times my a, which is 4. So I get 8 over 8, which is just 1. Good. How do you find y? Yay, plug it in. You know, you laugh when I keep saying that over and over and over again. Somebody tomorrow is going to come in and go, how did I find that other part again? I don't know. I try to be so obnoxious that, like, it sticks in your head. All right, so what do you get when you plug in 1? Wow, we heard a lot of different answers. It is negative 9. All right, so 1, negative 9. That is my vertex. I'm going to draw my dotted line so it helps me when I reflect. Let's make our xy table. What do you want to plug in for x? Good, that was a 1, so I'm going to go 2 and 3. If I plug in a 2, Negative 5, good. Just checking my mental math before I write it up there. If I plug in a 3, 7. Are we okay? Am I trusting Carrie?
Yes.
I should trust her. All right, so we'll graph 2, negative 5. And reflect. And then 3, 7. And reflect. Whew. Oh, did you guys see that graph? It's like the best one I've ever done. That was pretty a bad road. It kind of does. The road, like somebody's like, did you fall asleep when you were pouring the asphalt on that one? My dashed line looks pretty decent though, right? That's pretty good one. All right. So if I ask you then to solve, so 4x squared minus 8x minus 5 equals 0. What method do I know I cannot use? I can't use the square root method because there's a b term. So do we think it factors? Look at your graph. Do you think it factors? Maybe like, it's not really crossing it very nice. So to be safe, should I just quadratic formula? Okay. So negative b, which is 8, plus or minus square root b squared, so negative 8 squared, minus 4 times 4 times negative 5, all over 2 times a. A couple of you on your test did some real funky things with the quadratic formula. You know, that wasn't even the problem. I think only one person lost a point on not having a long enough, like, fraction bar. But no, some of you, I don't know what you're doing. Just type the whole thing under the radical. Just type it all in the calculator at one time. Stop doing it in pieces because you're messing up. Stop doing that. So what do you get underneath my radical? 8. 64. 4 times 4 times 5 is 144. So 8 plus or minus square root of 144 over 8. Which is 12. Wait a minute. Would this have factored? Is that a positive perfect square? Yeah, that would have factored. That's all right. So 8 plus or minus 12 over 8. I can divide all three numbers by 4. So if I divide by 4, I'm going to get 2 plus or minus 3 over 2. Do I stop there? I divided them all by 4. What's 2 plus 3? That's 5 over 2. That's one answer. 2 minus 3? Over 2. That's negative half. Oh, yeah, you would. You would. So real quick, take a look. Negative half. Yep, that's negative half, all right. So that's negative half. What's 5 over 2? That's 2.5. So that's right there at 2.5, or 5 over 2. So, yeah, that could have factored. Good. All right, we got one to go, guys. One to go. You go to lunch after this, but no, not home. Last one. All right, so graphing. Negative b over 2a. What's negative b? 12. Good. That was the classroom participation part. 2 times my a, which is negative 1. So 12 over negative 2, thank you, Carrie, is negative 6. How do I find the y? You plug it in. Now, stop real quick. You need that negative. So negative, parenthesis, my x value is negative 6 squared. Do we see that? Because people are going to mess that up. I need the negative in front. I do. Minus 12 times negative 6, minus 39. Negative 3, all of that for negative 3? All right, so there's my vertex. Negative 6, negative 3. That's what I would do. Hold on. Wait for your classmates to catch up. All right. So again, my x value is -6. So I'm going to go -5, -4. Okay? So if I plug in a -5, what'd you get? And if you plug in a -4? Anyone confirm nor deny these? You good? Okay. So we're going to graph -5, -4. And reflect. And then -4, -7. And reflect. Look at it, a baby. Ooh, that was a pretty good graph. I'm having a day of graphs, you guys. It's exciting. It's really hard to graph on the smartboard to like make sure it's in the right spot. It's very awkward. So looking at that, back to Lydia's question earlier, what kind of answers am I going to have? They're going to be imaginary because it does not cross the x-axis. So I know my answers are imaginary. I'm going to have to use the quadratic formula. All right. So to solve -b, which is 12 plus or minus square root b squared minus 4 times -1 times -39 all over 2 times -1. All right, so what do we get underneath that radical? What? -12? You guys confirm? Am I trusting him? Just I didn't type it in. Is it a surprise to you that that answer under the radical is negative? It shouldn't be. I didn't cross the x-axis. I know my answer is imaginary. All right, so if we do the factor tree here, so x equals 12 plus or minus, it's going to be 2i radical 3 over -2. I can divide them all by what? -2. Very nice. I don't want to leave that negative on the bottom, right? So if I divide them all by -2, so 12 divided by -2 is -6 plus or minus 2 divided by -2, -1. Do I have to put another negative? Do you see I already got both sides accounted for right here? I don't really have to worry about it. So just I radical 3. So if it does not cross the x-axis, it has imaginary answers. Come on, that's kind of cool today, right? I remember the day like I had that like realization like, oh my gosh, like all the solving I did is the same as if I graphed it. So you're telling me that on my test I could have just typed it in my calculator and graphed it and been like, oh look, there's my answers. Yes, you could have.